Why haven't we explored the oceans yet? The Earth's oceans contain roughly 321 million cubic miles of water, which is trillions upon trillions of gallons of liquid, stretching across more than 70% of our planet's surface area and amounting to roughly 99% of the Earth's total living space. And yet, there's still so much we don't know. This is Unveiled, and today we're answering the extraordinary question, why haven't we fully explored the oceans yet? Are you a fiend for facts? Are you constantly curious? Then why not subscribe to Unveiled for more clips like this one, and ring the bell for more fascinating content. First off, why should we even care about what happens in the oceans at all? These vast waters can seem like cold and empty, inhospitable environments threatening hidden dangers, but they're actually key to understanding our planet. Like rare plants found in the rainforest, there could be, and probably are, millions of undiscovered species living down there, which could change what we know, or think we know, about biology and evolution, as well as general sea life and life on Earth. For many, the uncharted plants, animals, and environments can mean only one thing: sea monsters. Taking the big fin, or long-armed squid, as an almost alien-like example of something we do already know about, is it so hard to believe that there'd be other enormous creatures thriving in parts of the sea human eyes have never seen? The biggest animal we're aware of is the blue whale, but we only know so much about it because it stays close to the surface to breathe. For animals evolved to live in the deepest, darkest depths, some argue they could be even bigger. It's certainly an idea embraced in mythology, with creatures like the Kraken, the Leviathan, and the Hydra showing up in stories and texts for centuries. But it's also something that even science can't entirely disprove, because so much of the ocean remains uncharted. As recently as 1997, ocean experts were left scratching their heads by the bloop, a loud, low-frequency, and unexplained sound detected deep underwater. Some said the sound was made by an impossibly huge sea creature moving. Others have speculated that it was simply shifting sea ice, but no one knows for sure. That's not to say that simply monsters is the reason humans haven't charted every inch of the underwater world. A lot of it rests on a lack of enthusiasm, and therefore technology to do so, arguably the result of a human tendency to look outward toward the stars rather than inward at the bottom of the sea. Oceanographers argue that the biggest roadblock for sea exploration is space. Despite the universe being incomprehensibly huge, we know much more about what happens out there than down here, spending much more time, money, and effort to do so. We've mapped 100% of the lunar and Martian surface and around 98% of our second closest planet, Venus, but only 5% of our own seafloor. There are valid reasons for this. NASA used radio waves to map other planets, but radio waves can't be used for the sea because the water gets in the way. Mapping the ocean floor requires sonar, which, though the tech does exist, is a much slower process. During the search for Malaysia Airlines Flight 370, for example, the sonar used was so advanced that massive active volcanoes, deep trenches, and other geological features were discovered for the first time while trying to locate the plane. Unfortunately, it often takes a tragedy like this for such a thorough and detailed analysis of deep-sea areas to even happen. Ocean authorities like the National Oceanic and Atmospheric Administration simply don't have the funding to explore the ocean on a large scale. Compared to NASA, NOAA feels extremely low profile, and that's reflected in their budgets, with NOAA pocketing around $6 billion in 2018 and NASA more than $20 billion. According to the University of New Hampshire's Larry Meyer, total sonar mapping of the sea could cost only half of what NOAA gets given, and around the same as a single mission to Mars, around $3 billion. But there just isn't the willingness to spend such massive numbers on the project. All of which means that most underwater mapping is actually done by private oil companies looking for places to drill, which represents an unfortunate irony for oceanographers, as underwater drilling can spell disaster for ocean environments. Those hoping to increase deep-sea exploration argue that it would actually benefit us far more than space travel anyway. Even if we did discover something exciting like alien life elsewhere in the solar system, we might not be able to make contact for centuries. Meanwhile, there's an arguably greater chance of immediate, life-changing discoveries at sea, where the research field is comparatively closer, smaller, and more manageable. While it's 239,000 miles from here to the moon, the furthest depths of our earthly seas, Challenger Deep in the Marianas Trench, are just 7 miles away from us, and humans have already been there. with the first ever manned submarine journey to the Challenger Deep happening as long ago as 1960, 9 years before the moon landing. There are problems beyond the simple lack of funding and apparent lack of enthusiasm, though, namely depth pressure. While space travel deals with a distinct lack of pressure, the pressure is immense for deep-sea missions. According to NASA, the pressure at Challenger Deep is 1,000 times greater than on land, and the same as if you tried to hold 50 jumbo jets on your own. But that is the extreme case. On average, the ocean is only 2.3 miles deep. The conditions are still pretty perilous, but not at the same kind of level. If we took the time to source the right location, then we could feasibly build an International Sea Station as an underwater counterpart for the ISS in orbit. The near total lack of sunlight would make it almost impossible to carry out some tasks in underwater bases, like growing plants for example. But there would be some benefits compared to outer space living too. At its coldest, the ocean dips only just below 0 degrees Celsius, while space is minus 270. So underwater heating systems would be under much less strain. It'd also be easier to send supplies to and from an underwater base since it's only a few miles in a submarine compared to a few hundred in a rocket. And those actually based underwater could return to land fairly often, while it'd be an arduous journey for anyone in a moon colony. Finally, if we did open up our oceans, then we could even find another solution to various global concerns like climate change and overpopulation: underwater cities. Currently, there's clearly a much greater emphasis on moving to Mars than on colonizing the Atlantic, but if we relocated the water en masse, it'd at least buy us some more time to reevaluate our lives on Earth, and give us a greater first-hand understanding of sea and plastic pollution. In the long term, such a move could even give us more time to tweak our space travel strategies.
People try to sneak in all the time.
Yeah, right.
Perhaps NASA and NOAA share a common goal after all. Whether or not we do eventually explore the entire ocean largely boils down to money and motivation, and whether there's enough of either. There are mysteries to solve, species to discover, and wide-reaching lessons to learn. But right now, we're impeded by inexplicable disinterest and an unfortunate lack of funding. And that's why we haven't fully explored the oceans yet. What do you think? Is there anything we missed? Let us know in the comments, check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.